In this video, we are going to learn how to make a half adder with 4-to-1 multiplexer. So I'm going to show you how to build this on a trainer. First, let's talk about what do I mean by half adder, what do I mean by 4-to-1 multiplexer. So as you know, multiplexer is a device that basically selects one of the inputs, right? So when you have a mux, for example, 4-to-1, that means you have 4 inputs, and at the output, you can select one of the inputs, and you have 2 pins here that helps you to select which input you want to see at the output. For example, if you say 0, 0, you will see D0. If you have 0, 1, then you will see D1. D1 will come out. Although D0 is here, but you will see D1. If you put 1, 0, then at the output, you see D3. And then when you have 1, 1, what you see is D4. So a 4-to-1 multiplexer selects one of the inputs, okay? So now I want to use this device to make a half adder. The question is, what is a half adder? Half adder is when you make a half adder, you are using 2 logics, exclusive OR and an AND gate. So here you have 2 inputs, A and B. One of the outputs is sum, the other one is carry. Because when you add 2 digits, you either add 0 plus 0, which is a 0, then your sum will be 0, your carry will be 0. What about 0 plus 1? 0 plus 1 is 1, so your sum will be 1, your carry will be 0. What about 1 plus 0? If A is 1, B is 0, what you see here is 1, 0. And 1 plus 1, if you put A equal to 1 and B equal to 1, what you see at the output is 0, 1. Because 1 plus 1 is 1, 0, so 0 is your sum, then 1 is your carry. 1 will be your carry. And 0 plus 0 for this circuit gives me 0. So because I get these outputs out of this circuit, it's acting like a half adder, meaning you can add 2 digits with them and get the right answer. So this is a half adder, this is a mux. I'm going to use a mux or multiplexer, 4-to-1 multiplexer, to get the same output as I get from a half adder. So how can I do that? In order to do that, I need 2 multiplexers. So if I have 2 multiplexers like this, 4-to-1 multiplexer, so I have 4 inputs here, right? And I have 4 inputs here, and I have switches that are controlling both these mux to see what output I get at the output. And so these switches that you see here are the switches that control which output I want to get out of these 2 sums, and they are basically, they have common switches. So let's call this S1, call this S0. And now if you want to use 2 mux as a half adder, you have to you have to preset the inputs. Okay? What do I mean by that? If I put the first input 0, this input 1, this input 1, this input 0, 0, 0, 0, 1, what I get at the output by, so what are my inputs now? It's S1 and S0 are my inputs, which are the same A and B here. And at the output, I should get sum and carry. So all of this is basically can do the job of this half adder. Why? Because it gives me the same truth table. Here, for this, what my truth table is A, B, sum, carry, right? So I have two inputs, 0, 0, 0, 1, 1, 0, 1, 1. 0 plus 0 is 0, carry 0. 0 plus 1 is 1, carry 0. 1 plus 0, 1. 1 plus 1 is 0, 1. So this is a truth table of this circuit. This is a truth table for half adder. Now I have to get, if I get the same truth table from this, that means that I have built, it's doing the same job. Okay, so let's see. My inputs are S0 and so these are my inputs. And for my output, let's see. 0, 0, I have sum and I have carry, right? I show it with C. So if you have 0, 0 here, you get 0 out of sum and you get 0 out of carry, so that's good. If you have 0, 1, 0, 1, you get 0 from this, right? But then the switch for this one, sorry, 0, 1. If you have 0, 1 here, what you get out of this is 1. What you get out of here is 0. Now, if you have 1, 0, you get this out. 1 from sum, you get 0 from carry. If you put 1, 1, then you get 0 out of this, 1 out of this, right? So this is exactly the truth table as I had for my half adder. So this would do the same job. Now now I'm going to make it on a breadboard with the IC that I have. The IC for MOX that I'm using is 74153 IC. So this IC actually has two 4-to-1 MOX inside, which is perfect to make this. So if you look at the IC, this MOX IC, I'm going to draw what you see inside. So inside, first of all, you know that when you have a circle here, that means that's the top of your IC. And then this IC has 16 pins. So 1, 2, 3, 4, 5, 6, 7, 8. Then you have 9, 10, 11, 12, 13, 14, 15, 16. Okay, so this is 74153 IC, which I told you it has two MOX, 4-to-1 MOX inside. That means there is one MOX inside that is, if I want to make it simple, I can draw it for you to, so this would be 13, would be something like this. So I have two 4-to-1 multiplexer. That means that the output of pin 3 will be my first, this, you see, this MOX is the same as this one. So I have 4 inputs from these pins. So that's that, and that. And that would be 4 inputs. What about this one? It goes from this, this, and this are your 4 inputs. Then you need output, right? So the output of your mux, 4 to 1 mux, you can see it in this pin 7. So this is pin 1, 2, 3, 4, 5, 6, 7. The output of this 4 to 1 mux, you can see it in pin 7, at pin 7, and the rest is 3, 4, 5, 6. If you come on this side, you have 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Okay, so 14, 13, 12, and 11 are your input, and your output will go to, actually, no, it's 13, 12. I don't think oops. So if this is your IC, your output will go to 9, and your inputs are 10, 11, 12, 13, not 14. Okay, 14 is not one of your inputs. Okay, how does it look? So this is another 4 to 1 mux. Okay, so again, this is a 4 to 1 mux. 3, 4, 5, 6 are your inputs. 7 is your output. This one, 13, 12, 11, 10 are your inputs, and 9 is where you see the output of your mux. Pin 8 should be connected to ground, and pin 16 is where you power your IC with 5 volts. Okay, so you might ask, what about the other pins? You know, now I have everything, but what I'm missing are these 2 switches to control the output of my mux. Those switches, S1 is, so that means I'm missing this part, right? This part. So that part, if I come here, would be S1 will be connected to pin 2, and S0, you go back, S0 is connected to this one, which is connected to pin 14. Okay, so these are my switches to S1 and S0. So I have everything that I have here on this IC. The next thing you should know is the strobes that basically control your multiplexers turn on and off. So those strobes are connected to pin 1 and pin 15. So pin 1 and pin 15, they should be, if they are connected to ground, that means that your multiplexer will work, both of them. If you connect them to high or high voltage or leave them open, you always get 1 at the output. So if you want your mux to work, you have to connect pin 15 and 1, your strobes, to the ground to make your IC work and get the outputs that you want. Otherwise, you get 1 at the output. Okay, so this is what we are going to do. Now, before building this, what inputs should I give to my to my two muxes? So for the first 4 to 1 mux, I have 0, 1, 1, 0. For this one, I have 0, 0, 0, 1. So I'm going to ground these two pins and connect these two pins to high. I'm going to ground these 3 pins here and put this to high. So if I come here, I'm going to connect this to 0. So S1 is my switch, right? This should be connected to ground. I'm going to show it with blue. Blue ground and red high. So this is ground. S1 should be connected to your switch. And then these pins, these 4 pins, the 3, 4, 5, 6, I'm going to connect it to 0, 1, 1, 0. So 0 is ground. So 3 is ground, right? And then 4, 5, they should be connected to high, which corresponds to 1, 1 here. And then the last one, 0, which is ground. And 7 is your output. So what I do in the lab, I'm going to connect an LED here, and if it's connect this side to ground, that means whenever I get 1 here, it should turn on. So I would know that I get high at the output. So that's this side. This should be connected to switch, right? This is pin 2, and this is your switch. Going to write it with switch. So that's your switch that you turn on and off, which represents these switches here, which are your inputs for the half adder. Okay, what about the right side? So 9 is your output again. So that will, you put an LED here. 15, as I said, it's your strobe, so you have to connect it to ground. So your mux will select the input that you want, so that will be ground. S0 is your switch. 14, pin 14 is your switch. Then what about pin 13? Pin 13 is 1. Pin 12 is 0, right? Pin 11, 0, 10, 0. If you are confused about this, these are exactly these. 0, 0, 0, 1, the inputs of MUX 2. I have to preset the input in order for my switches to give me the outputs I want. So that's what I'm doing here. But I'm going this way because this is my D0. So this is D0, D1, D2, D3, 0, 0, 0, 1. And here I'm connecting my LED. So the output of LED, if I want this to be 1, then I have to connect the other leg to ground to work. So eventually I have to build this on a trainer. I'm going to show you how to build this on a trainer, and you just follow what I do here. So 1 will be ground, 2 switch, 3 ground, 4 high, or your 5 volts, 5, pin 5 high volts, 6 ground, 7 your LED with, so LED has 2 legs, right? Short leg is negative, connected to ground. Long leg will be connected to 7. 8 will be connected to ground. 16 from top, right side, VCC or 5 volts. Ground, switch, positive or high, 5 volts, ground, ground, ground. And 9 is your LED high. And connect the other leg, the short leg, to the ground. After this, I'm going to move on a breadboard and show you exactly what you see at the output. Now this is the circuit. I have 5 volt that I connected to my pin 16. to power up my IC, and you need to connect pin A to ground. Then I have my two switches that are connected to 14 and 2 pin numbers, and those are my switches. Then my strobes are connected to pin number 1, so you have to connect it to ground, and the other one is connected to pin 15, so pin 15 should be connected to ground as well. The rest are just your inputs for multiplexer. The highs, I just left them open because for this IC, when you leave it open, it will consider it high. So that will decrease the number of wires that you use. Okay, so here is 1, 0, 0, 0, and here you have 0, 0, 1, 1. So what it should do is that when your switches are both switch 1 and switch 2 that I connected, if they're both 0, you have 0, 0, 1 is your sum carry. This is your sum carry, sum is 1. And then if I do that, sum carry again, for 1, 1, I should get 1, 0, right? So if I put them both on my switches, I get 1, 0. That's it. So now you have a half adder. You just made a half adder using two 4-to-1 multiplexers.